Welcome, we present CARI4D, category Agnostic 4D Reconstruction of Human Object Interaction. The goal of this project is to reconstruct 4D human-object interaction with accurate contacts from single monocular RGB video as input. We do not assume any template shape, but reconstruct them from input video. This is a very challenging problem due to unknown shape, depth scale ambiguity, and dynamic motion with occlusion. Previous method. VisTracker simplifies the problem by assuming ground truth object template. This produces consistent translation and good mesh, but it requires template and is limited to specific object instances. Recent method InnerTrack is template-free, but it can only reconstruct point clouds and produce inconsistent translation. It still works only for limited object categories. What we want is a method that is template-free, has consistent inner frame translation, and generalizes beyond fixed categories. Our key idea is first leveraging foundation models in shape reconstruction, pose estimation, and scene understanding. This is, however, non-trivial as the predictions lie in different space and they can suffer from noisy input. Our solution is to align the predictions and learn a model that reasons interaction but is category agnostic. This is an overview of our method. We start with initialization using foundation models and then learn a model to reason contacts and refine interaction poses, which are then used to further improve the realism of the contacts via optimization. Please see our paper for more details. We evaluate our method on the behave and unseen intercap dataset. Our method outperforms previous methods by 38% in behave and 36% in unseen intercap dataset. We now show video comparisons. InnerTrack can only predict point clouds as output, and the predicted shapes and poses are noisy. In contrast, our method reconstructs good shape at metric scale and tracks the pose and contacts accurately. We now compare with VisTracker on behave. We send our reconstructed object mesh as the template for VisTracker, but it still predicts noisy poses. On the contrary, our method can reconstruct good shape and tracks the interactions accurately across the full video. We now compare in the unseen intercap dataset. Note that all models were not trained on this dataset. Pico retrieves contacts from predefined database, which can be noisy, leading to inaccurate optimized poses. Our method reconstructs the shape and contacts on the fly coherently. We now visualize the top-down view. It can be seen that image-based method Pico always predicts human and object at the same location, while our method produces consistent translation across the all video frames. We also compare with VisTracker on intercap. We input our reconstructed mesh to VisTracker, yet it struggles to generalizes to unseen instances, while our method generalizes much more stable. We now show results in the wild internet videos. Pico queries object from predefined contact database, which can be very limited, and the queried object as well as contacts are inaccurate. In contrast, our method produces correct object shape reconstruction and more stable results. We compare with InnerTrack in this video. It outputs point clouds that look plausible in front view, but are inconsistent in 3D. Our method reconstructs accurate shapes as meshes and tracks the poses and contacts accurately. We now compare with VisTracker. It fails to generalize to the unseen object from in the wild, while our method generalizes well in both shape reconstruction and interaction pose tracking. We show another comparison with VisTracker. It predicts completely flipped object pose. Notice how accurately our method reconstructs the metric scale object, human poses, object poses, and contacts from just monocular RGB video. Thank you for watching. Our code and pre-trained models will be publicly released.